Welcome back to the deep dive. Today, we're stepping into the very intense world of high-stakes construction. Think massive power plants, complex industrial facilities, and we're zeroing in on that single most critical moment, proving the whole thing is actually ready to go.
We're looking at what's really the gold standard for this stuff,
Yeah.
FIDIC 2017. Specifically, the rules around what are called tests on completion, or TOC.
Right.
For these billion-dollar projects, this isn't just a test. It's the ultimate legal gateway to handover.
And that's the mission for you today. We are going to map out the rigorous contractual choreography that's required to prove a project is truly finished.
Exactly.
We'll follow the deadlines, we'll look at the phases, and we'll point out some surprising legal traps. The big insight we want you to take away is this: the legal timing, the paperwork. It can often override the physical reality of the engineering.
That's absolutely right. I mean, completion isn't just about the structure being physically built. It's a strict legal procedure. You could have a perfect plant, but if you miss a deadline by a day, the contract says you failed.
Okay, so let's unpack this. Before the contractor can even think about firing up the machinery for testing, there are some prerequisites, right? Some paperwork.
Yes, a couple of crucial deliverables that basically act as gatekeepers. First, the contractor has to submit the as-built records.
Which are the final drawings of what was actually built.
Exactly. And second, they have to provide the operation and maintenance manuals. Basically, the instruction book for the employer on how to run and fix everything.
Makes sense. You can't hand over the keys without the manual. So then we hit the timeline, and this is the first big hurdle. How far in advance do they have to plan all this?
Well, in advance, the contractor has to submit a really detailed test program, timing, resources, procedures, everything, a minimum of 42 days before they even want to start the test.
42 days, so a full 6 weeks.
A full 6 weeks. And that just tells you how much detail has to be in that plan for the engineer to review.
And I imagine the engineer can't just sit on that plan indefinitely, can they?
No, they can't. The contract gives them a very tight window. They have exactly 14 days to review it and issue a notice if they find something that doesn't comply with the contract.
And this is where we see one of those really interesting contractual mechanisms, something called deemed approval. What happens if the engineer just gets busy and doesn't respond in those 14 days?
Then the engineer is legally deemed to have given a notice of no objection. It's a critical protection for the contractor. It means they can't be held hostage by inaction. Silence, in this case, legally becomes consent.
Wait, let me get this straight. So if the engineer just ignores the paperwork for 2 weeks, the contractor can just move ahead?
They can.
Isn't that risky? What if the engineer really wasn't ready?
It is risky, but it puts the responsibility squarely on the engineer to do the review. The key thing is, the tests absolutely cannot start until that card. No objection, whether it's an actual notice or just a deemed one, is confirmed. The risk shifts.
Okay, so the plan gets the green light, one way or another. What's the final signal before they actually start the tests?
The contractor gives one more notice, a final readiness notice, and that has to be given not less than 21 days before the plan's start date.
So another 3 weeks?
Another 3 weeks. And once that date arrives, the tests must start within 14 days after it. It's this very precise countdown.
So once that whole planning dance is done, we move from paper to the actual plant. The contract breaks the physical testing into 3 very distinct stages.
And they're highly sequential. The whole point is to manage risk. You don't turn on the full power until you know that basic wiring is safe.
So tell us about Stage A pre-commissioning tests.
This is the foundation. It's all about inspections and what we call dry or cold functional tests.
What does that mean, dry or cold?
Think about running plain water through pumps instead of chemicals, or testing electrical circuits without putting them under full load. It's all about demonstrating that the works can safely move to the next stage. It's the safety check.
Got it. And that brings us to Stage B, the commissioning tests.
Right. This is where the system starts operating as it was designed. The whole point here is to demonstrate safe operation under all available operating conditions that are specified in the contract. You're testing the machinery in motion.
And finally, Stage C, trial operation. This sounds like the endurance run.
It is, exactly. This is where the plant is run under stable conditions for a defined period. The purpose is to prove it can perform reliably. If it's a power plant, this is where you see if it can actually run at 95% capacity for a week straight without failing.
Now, I saw a really surprising economic detail about this stage. While the contractor is still responsible for the plant, any product that's made during this trial, so electricity, gas, whatever, and any revenue from it, immediately belongs to the employer.
That's a really important point. The commercial benefit shifts to the employer the second those products are created. But, and this is the key distinction, the contract is very clear that this trial operation does not mean the employer has formally taken over the project.
The contractor is still on the hook for any defects?
Still on the hook.
Okay, so the contractor has passed all 3 stages. They're done. What's the next step? Back to the paperwork, I assume.
Back to the paperwork. For each stage they pass, the contractor has to submit a certified report of the results to the engineer.
And we're back to that tight turnaround for the engineer, and the silence is consent rule.
We are. The engineer has, once again, only 14 days to give a notice of non-compliance. If they think the results are off, even by a tiny margin, they have to object. If they don't,
It's deemed a pass.
it's deemed a notice of no objection, and that stage is officially complete.
Now, there's a fascinating bit of nuance here. What allowance does the engineer have to make when they're looking at those results?
They have to be fair. The contract says the engineer must make allowances for the effect of any use of the works by the employer. So, if the employer was using part of the plant to train staff during the test, for example, the engineer has to factor that interference into the final performance numbers.
That prevents the employer from, say, subtly sabotaging the test to avoid payment. Okay, let's shift to the dark side. Delays. Who carries the risk when the testing schedule slips?
The contract is very clear. If the tests are delayed by the employer, the contractor is protected. They can claim extensions, costs, and so on.
But what about the more common scenario where the delay is on the contractor's side?
If the contractor is the one causing the delay, the engineer has a very powerful tool. They can issue a notice requiring the contractor to carry out the tests within a hard window of 21 days.
21 days. The last chance saloon.
Pretty much. And the contractor has to pick a date within that window and give the engineer at least 7 days notice.
And what if they miss that deadline? This is where the contractor really loses control, isn't it?
Completely. It's an ultimate transfer of risk. If the contractor misses that 21-day deadline, the engineer issues a second notice. And then the employer's own people can just go in and do the tests themselves.
Oh, forced testing.
Forced testing. The employer basically takes the keys, runs the tests, and sends the bill to the contractor.
And any costs the employer incurs in doing that.
The employer is entitled to recover all of it from the contractor. It's a direct financial penalty for the delay.
And here's the kicker. Whether the contractor even shows up for this forced test or not, what does the contract say about the results?
It says the tests are deemed to have been carried out in the presence of the contractor, and the results shall be accepted as accurate.
So they lose the right to even argue about the results.
They lose everything. That's why those deadlines are so critical. You miss them. You surrender your right to defend your own work.
That is a huge shift in power. Okay, let's go to the ultimate scenario. The works actually failed the initial tests on completion. What happens then?
An initial failure isn't the end of the world. It triggers the contract's rules on defects and rejection. Basically, either side can require the failed test to be repeated. You go back and do it again.
But what if they fail the repeated tests? This is where the engineer gets some pretty drastic options, right?
Yes, 4 of them. And the severity really ramps up. Option A, they can just order more repetitions of the test. Costly, but simple.
Okay.
Option B, they can reject the whole works. If the failure is so bad, it deprives the employer of, and I'm quoting, substantially the whole benefit of the project.
So the project is basically useless.
Exactly. Or C, they can reject just a specific section if that part can't be used. But it's option D that's the most.
Fascinating. What's D?
The engineer can issue a taking over certificate anyway if the employer requests it.
Hold on. The employer can request to take over a project that has just failed its tests.
Yeah.
Twice. Why would anyone do that? It sounds like it lets the contractor off the hook.
Oh, it doesn't. Not financially. If the employer chooses this, they are then entitled to a reduction in the contract price. They essentially say, fine, I'll take this broken plant, but you are going to pay me for the loss in value and for what it will cost me to fix it. The contractor doesn't fix it. They just pay for the failure.
This has been an eye-opening dive. It really proves that great engineering is, well, it's just not enough on its own.
Not at all. The real value here is seeing that success is about navigating this rigid procedural framework. It all hinges on these deadlines, 42 days, 14 days, 21 days. They're not suggestions, they're control mechanisms.
And you can see how the contract tries to balance that power. The contractor gets protections like deemed approval to prevent them from being stalled forever.
Right, but the employer gets these incredibly powerful remedies, like forced testing or the option to take over a failed project for a discount.
It's a high-stakes, risk-managed environment where every day on the calendar matters.
Immense.
So, to leave you with a final thought to mull over, consider that ultimate failure scenario, 9.4D, where the employer takes a failed project for a price adjustment. What unexpected risks does the contractor suddenly face? This choice completely bypasses the normal defect repair process, and well, it instantly transforms a technical engineering failure into a long, complicated, and probably very nasty valuation dispute over how much a broken project is actually worth.
It turns an engineering problem into a legal and accounting nightmare. Something to think about.
Thanks for diving deep with us. We'll see you next time.